All right, guys, this is the last lesson of this unit. And in this lesson, we are going to continue what we learned in 2.5, which was the calculator stuff that we did in class. So this is actually the same example, the one about the trees. We had the height of the trees and the diameter of the ring. And so if you look back in your notes, this was the equation that we found when we put the linear regression in our calculator. So what we're going to do this time is we are going to start interpreting the slope, the y-intercept, and the x-intercept. So let's start with slope. So this is our slope right here. The slope is the one right before the x. Now slope, you remember, is actually a fraction. So if you will look, I took that slope and I put it over 1. And then I have to decide. So remember, slope is change in y over change in x. So I looked to see what was the label for the y-axis, and that was feet. And this should say height in feet instead of feet in height, but that's okay. So we know that it was in feet, and we were talking about the height of the plant. And then the x was the diameter in inches. So I look at this, and what this is saying is this is increasing 3.179 feet in height for every 1 inch in diameter. That's a positive. So if you look at the words, I say for every inch in diameter the tree grows, its height will increase on average. That's an important word that you say right there, on average, 3,179 feet. And I think that's supposed to be 3.179 feet. So that's how you interpret slope. You have to take your slope, you put it over 1, and then you put your labels on it, and then is it increasing or decreasing, and you have to label it that way. Now to interpret y-intercept, of course y-intercept is at the end. It's the constant that doesn't have a variable. And so it was, that should be equals, b equals 1.536. Now this means b or y is 1.536 when x is 0. So now remember, x is inches, it's the diameter, and y is feet, talking about the height. So in words, this means when the diameter of the tree is 0, so here was the diameter of the tree, the height would be 1.536 feet. Okay, now to find the x-intercept isn't something that you can see from your equation. So to find the x-intercept, you have to make y equal to 0 and solve for x. So in our equation up here, it's y equals 3.179x plus 1.536. You have to make y 0. So instead of y, we put 0. And we would have to solve for x. So you would subtract 1.536. And you get negative 1.536 equals 3.179x. Divide both sides by 3.179. And you should get x is equal to negative 0.483. So this means our coordinate is negative 0.483, 0. And remember, this is in inches with the diameter, and this is feet for the height. So to interpret that, it's when the height of the tree is 0 feet. That should be 0 feet. Let's fix that. 0 feet. The diameter would be negative 0.483 inches. There we go. We fixed our mistake in the notes. All right. So that's how you find and interpret slope, y-intercept, and x-intercept. Now here's just a quick review for correlation. Remember, positive correlation is when your dots are going in a positive direction. Negative correlation is when your dots are going in a negative direction. And no correlation is when you can't see a pattern on your scatter plot at all. So sometimes with these, we have the tendency to say the correlation is strong, so one thing causes another. So this takes us to looking at relationships, and is it just a strong correlation, or does one thing actually cause the other? So it says the following graph depicts the relationship between the sales of ice cream and the temperatures according to the weather recorded each day. So this is saying that as the temperature increases, the sales of ice cream increase. So definitely a strong correlation. But do you think that the temperature increase causes the sale of ice cream to increase? I would say that we also have causation here. Okay, so let's look at the next one. This is the Mexican lemon imports. And the headline, this is actually a headline from a newspaper. Mexican lemon imports prevent highway deaths. So if you look down here, these are the number of fresh lemons imported from the United States to Mexico. These are the total United States highway fatality rates. So it's a very strong negative correlation. But can we say that lemon imports cause highway fatalities? There's no causation here. And the reason we look at these is because we don't want to say just because the correlation is strong that it causes it. All right, so it says, is there any relationship between student scores on an examination and students' cumulative grade point average, or GPA, upon graduation? So here, whoops, wrong example. So do you think, so it's saying relationship between student scores and cumulative GPA upon graduation. Probably a strong correlation to this, but do you think that a student's scores on tests would lead them to have a stronger GPA upon graduation? I would say this one is also a causation, because I think better test scores would lead to a better GPA. Okay, so let's look at this example here. Global average temperatures versus the number of pirates. All right. So here's the number of pirates that we have. And here's our global average temperature. Once again, a very strong, positive correlation. But do we think that the global temperatures have anything to do with the number of pirates? I'm going to say probably not. So we would say in this situation, no causation. Okay, so I would like for you to look at this first part of your homework. This says go back and answer all of the starred questions in 2.5. So you're going to interpret slope, interpret y-intercept, and I want you to do even the even numbers, which means if you didn't find it the last time, you need to go back and do it this time, because you probably need more practice. Then question 3, notice I skipped question 2. I know, I did it on purpose. It says go back and find the x-intercepts, and remember we have that example, but I was kind enough to tell you again how to do it. Substitute for 0 into the y, and then solve for x. And then this one, I want you to do just the odd numbered questions. And then go ahead and do the odds for the rest of these. These are identifying if they are only correlation or if they are also causation.